All right. I don't have it. I have to close that tab. All right, so I'm just going to do today's lecture in office hours format. So if anyone has any questions, we can go over those. You wanted to talk about callbacks versus promises.
And what the difference is.
Okay.
Let's be examples.
Yeah.
Also, I wrote here, running a test in mocha is the whole process, including connecting it in a JSON file with the script, because there's something I'm missing.
What JSON file?
When you know how like when you mocha
Yeah.
and you have to put like in the script, what file it connects to.
What's script? So package JSON. So package JSON, you have to say that mocha and chai are dependencies, and then you have to say like, and when you run npm test, what's that gonna do? And so you say run the mocha command, and then here's the test files for you to run, right?
Yeah.
So you want to talk about setting that up? Okay.
Yeah.
Let's just do setting up mocha. Cool. Anybody got anything else?
Setting up a footer, setting up a footer with Flexbox.
Okay, HTML footers with Flexbox, maybe a sticky footer.
Yeah.
All right. Yep. Just in general? Like what? Let's get specific.
I guess joining tables. Yeah.
Joining tables? Okay.
Yeah. Joins, period.
All right, I can give a little intro to that. Cool.
Can we talk about regular expressions?
You can, yeah. What do you want to ask about? Any questions in specific about regular expressions?
Like how to make
Okay, I'm not sure what I'll do, but we'll get there. Maybe you'll have a better question or a more specific question when we get there.
Okay.
All right, great. What is this? All right. Okay. Okay, great. So let's talk about callbacks versus promises. What? How can we illustrate this? All right, so let's see. All right, so this is an example of a function that takes a callback. So you would do something like this, right? So we ask whatever it is we're doing, an HTTP request, reading a file, anything that takes asynchronous time to do it, anything that's non-blocking, right? So here I'm using in the example set timeout just because that's going to be an example of something that blocks for here 100 milliseconds, yeah? So maybe we'll get more well, so anyway, is this too general? Does this not make sense if I just say do something? Should we use a specific example, or does everybody can follow this? Yeah? So this is an example of a function that's going to wait 100 milliseconds, and then it's just going to return the string something, but, well, not return, right? It's going to result or resolve with this result, and it does that by calling the callback. The standard way here would be like to pass, at least a node standard way would be that callbacks always receive an error if it happened first. So we might do something like, whatever our work is, we might catch any errors that happen there. And if there was an error, we pass it, else else we pass the result back, right? Something like that. So anyway, the error handling is not that important. But what's the difference? So how would we do this with promises? So a promise version of this would look like this. And then we just do something. So we'll do our set timeout. Oh man, we're getting stuff open. I'm gonna try to mute people. Oh, not contacts. Participants. Mute. There we go. Okay, so cool. So we create, there's a couple of different ways we could do this. In this case, in this example, I'm going to make a new promise. And so I'm going to set timeout for 100 milliseconds, and then I'm going to try to set this variable, which obviously will never fail. But instead of calling callback, which we don't receive, we actually call, in the case of an error, we call reject. And in the case of success, we call resolve. So, and then the call code is different. You just call it and it returns a promise. So you can either store that promise and attach a callback to it. But usually you just chain off of it. So we'll just say do something, then, and if we want to handle the error, we say catch. Okay, so it's a little bit different here. We'll say if there's an error, we'll do something, we'll handle that error, else we'll deal with we'll go forward with our result. Instead of an if statement like that, down here we're going to pass two different callbacks. So we call the catch method, give it a callback, and then we call the then method and give it a callback. And this will go, and if it fails, this will get called, and if it succeeds, this will get called. So to look at this in a simpler way, if we wanted to just do a synchronous thing, we could create a new promise and just resolve it with 42 right away, and it would just, on the next JavaScript thread, the then function is going to get called because it was resolved successfully. If we wanted to reject this, right, we could just give it a new error. And the reason, so there's these two different syntaxes, right? One, we give a function and we call that function either with the error or without the error and the result. In the promise version, it sort of takes care of that calling, instead of calling the same callback in a different way, we actually get to call two completely different callbacks, depending on whether or not our promise was resolved or rejected.
So like under the hood though, what's like fundamental design differences between?
The differences are in the API, right? So let's say the differences are how we use it. So let's say we have several, let's say we have some several functions here that we want to run. We have a job that we want to do. So we want to read the file, and then we want to parse that file, parse the file. And then we want to, I don't know, extract data. These are all just made up, and then print results. Let's say these are all asynchronous functions. Yeah? So if we were doing callbacks, the way we would do this is we would pass this a callback. Oh, that's not good. But we would have to nest these things. So each one of these would get nested in the previous one, and we put our error handling at the top. So we end up getting this little nested tree here, right? So if error, this is the simple case. We probably would do something more complex in the case of these errors, but that's the simple thing. And then this is probably going to be like file contents, and then this will be like maybe we pass this down to this function. So then we get back the data, and we pass here, and then we get you know, extracted data, and then we pass that here, and then we don't even care about the return value of this because it just printed to the screen or something, right? So here's how we would do these 4 asynchronous steps. And so the first read file calls our callback. If there was an error, we throw it. Otherwise, we get the contents and we pass it to parse the file. And then it does its thing, and we get data and pass it here. So you can see how the data from the result of the previous object is being sent to the next object, yeah? So how would we do this with promises? We would do something like this. Read the file, then parse the file, then extract the data, then print the results. We would have to structure these functions differently, but we could do something like this. And then actually we would have to have a dot catch at the end where we, if there was an error, we would throw that error, or again, handle that in some other case. Maybe we log it, exit our program, render a 500, whatever we need to do. But you can see this is a much more terse syntax here, right? It's also in a vertical line instead of each next step is nested, right? We get this sort of regressive, infinite regress, right? We get this every step we have to do, we have to indent one more time because it's callbacks and callbacks and callbacks, right? So promises were created so that you can do this linear looking code. And so what the plumbing of promises is doing is all of this code runs right now in line, and it builds this returns a promise, this returns a new promise, this returns another new promise, and we're chaining promises. We're saying, once you've done this, then do this, and when that's done, do this, and when that's done, do this. And one of the really nice things is if you put catch anywhere in here, it will catch any errors that happened in the history of those chained promises, right? So if there's a failure in any one of these 4 functions, if any one of them throws an error, it falls through. So if read the file throws an error, it falls through and it skips all these and goes down to the next catch it can find. So if I want to know if there's a specific error in read file, I can catch that here, and I can handle it, and I can return a new value. Let's say I could fix that error somehow, right? Then I could return a new value. Then that would progress down to the next then. So you know, if let's say if I try to read the file and I have some way of fixing it. So let's say the file name is like a.txt, right? And that throws an error, and I know that like, okay, if it's not A, it might be B. So I can actually return. Here's another really nice thing about promises is I can actually return a promise from any one of these functions, and it will wait for that promise. So you can kind of slip new promises in between, right? So this returns a promise which says when it's successfully resolved, do this parse the file thing. But if there's an error, I can return a new promise, which then this promise will wait for. So it provides this API that does things asynchronously in JavaScript, but allows you to write code that kind of looks synchronous. It kind of looks serial. And, well, and it actually is serial. It's just jumping over multiple threads. It's not serial in the single file, single thread, like A, then B, then C. It really is going to be running asynchronously through all these steps, but it's just event driven, right? When this is resolved or rejected, we either call this or we call the next one. If this is resolved or rejected, we either go to the next one on resolve or we fall down to the catch on reject, right? So it's a totally alternate API. But it's meant to make this complexity, which you can, if we 10x this complexity, right, you can see how it'd be really challenging. We can make, what we used to have to do if we didn't want to have this infinite regress is take these functions and name them, you know, on print results complete, you know, we would store this up here and then we would pass this here. You know, there's a couple of tricks you can do for formatting that would make this stuff easier to read, but ultimately the Promise API just makes it really clean to be able to say, do these things in series. And you can also say, really easily do these things in parallel, which actually was way harder, right? This is for a serial set of events. If we wanted to do a parallel set of events, right? Let's say we were going to do read file as our function, and we wanted to read 4 files, right? So we're going to read a.txt, b, c, and d, right? So if we want to read these files, if we're doing callbacks, right? Okay. So if we were going to do callbacks, how would we know when all 4 of these are done and get the results of them, right? We could do them in series by nesting them, read A, then B, then C, then D, but that would be a little bit slower than doing them in parallel, right? So if we're doing these all in parallel, we'd have to do something like we'd have to store the file contents, maybe in an object, and then in each one of these functions, we'd have to like store the file contents. And then we'd also have to check, like, am I the last one? Am I the last file to be read? And because then we got to go to our next step, right? So it's actually really complicated. We would end up wanting to use something like the Async Library to say, do these 4 things and wait for them all to be done. And it manages that for us so we don't have to manage it ourselves, right? But with promises, you can just do promise.all, give it an array of promises. So now if this, if read file returns a promise for us, we just say, wait for all 4 of these promises to complete, and then the results is actually just an array of the results of these promises in order. So this is file A's contents, and B, and C, and D. So now you can do things like read these 3 files, and then parse, you know, all 4 files, and then, you know, do whatever's next. And any of these things in here can actually have, you know, another promise.all in the mix here, and you can do some other, you know, parallel step, and then another serial step, or whatever, right? And if there's an error in any of that stuff, it can all get handled by a single, if you want, a single error handler, where we just maybe log the error and exit the program. So it provides this really nice alternate API that honestly is a little counterintuitive, and I found it a little hard to wrap my brain around when I first started playing with it. I really had to just sit down and write a bunch of bullshit code like this, where I'm reading some random files, and then I'm doing this next step, and I'm logging all the way through, and I'm seeing the actual order that things are happening. But it ends up giving you a pretty nice tools chain to say, do this in parallel, then do these things in series, then do these things in parallel, then do these things in series, and it can broker all of that for you. Can I what now? To this part here? Yeah.
You get an error at any one of those promises, and then it like tosses it down the cache. Everything else stops, right?
These things will never get run if your if you're handling and so if an error happened in parse the file and we're handling it here, even if we return here to keep going, which there is nothing left to do, but if we did, we could return to keep going. These things will never happen because we skipped them, right? So if I wanted to if I needed to catch an error and I could resolve it to keep going, I could put that here, catch the parse error. Maybe I'm parsing the wrong type or something. I try a different type, and then I keep going down. So in that case, I wouldn't throw the error. I would somehow rescue from the error and then return a new thing that becomes the input argument into extract data. So, you know, somehow, right? So we could do parse the file, you know, as JSON, and then if that didn't work, we could return parse the file as, you know, XML or something. Whatever, this is bullshit, right? But whatever would rescue from your error, if possible.
So as far as like the web scraper with callbacks and then doing it with promises,
which is phase 2 modules, by the way.
okay. They're essentially just asking to kind of create like a promise chain for getting the stuff back.
Yeah, so there's this what's the to-do list with promises, or which one was it?
The movie scraper.
The movie scraper, right. So there are several movie related modules. The idea behind those is they get progressively more complex in terms of like asynchronousness in JavaScript, right? So the first one you do with callbacks, and the second one you do with promises, right? And the third one you build a web app that does an HTTP API. So we're trying to like use that as like a single theme to do the same work, but present it on the command line with callbacks, then present it on the command line with promises, then present it as an HTTP API. And then a nice thing there is you can then go back and change your command line interface to use the HTTP API. So you're starting to build piece by piece the complexity of the web, but using also a simpler command line interface to learn some of these basics, right? So in all of phase 1, we don't ask you or require you to do anything with promises. We don't actually have we shouldn't have any asynchronous code at all. You will have some callbacks, but they're generally like for each and map and stuff, so synchronous stuff. And so you want to master the callbacks first, and then move to promises. And maybe in between those, you can use the Async Library. I'm thinking about adding a module for that that show you how to use how to do some of this stuff where you say like, I want to do this in parallel, and then this in series, and then these things in parallel. There's an async library that's been around, I think, longer than promises existed, where it's an API for doing this kind of definition, but using functions that take callbacks, and it manages like passing the right callback. And so, does that answer your question? Cool. You had a question?
In regards to you did. So
This one did these things down here.
scroll up.
Oh yeah, this thing.
Yeah. So when you do like the rescue from error, that idea, could that be applied in a situation where you're expecting an input that's like, say, an object, but you get like a string, for instance, and then you have like an alternative way to deal with like the wrong input?
Sure. I mean, in that case, you might if you're talking about you have a function that expects to get an object, and it was given a string, right? In that case, you could just say like, you could just do an if statement that says like, if it's rescuable, right? If we know how to convert the string to the object we want, like let's say it's a string of JSON and we need to parse it, then you could just say like, is my argument a string? If so, change it to the parsed version of that, right? You wouldn't have to necessarily catch the error, right?
I'm just trying to think of like, when would you rescue from an error? Like, when is that actually something you do?
Man, there's so many times when so a really important example is when you're building web apps and you're dealing with requests and needing to serve appropriate responses, right? So if I have an API where I'm just doing a get to /API/posts, right, for a bunch of blog posts, right? Or rather, actually, let's say I'm doing a post to API post because someone is creating a blog post, right? So they're posting some data. And so in my handler, I'll use express code to do this. I'll do app.post, API posts, and we have a request and a response. Oh, God. Request. Okay, and so we might want to do something like, and I'm going to pretend we can do this synchronously. We can't. We're going to have to use callbacks and promises for that. So we generally don't have to do a try catch like this, but I'll show you, right? So we'll do like a try, and we'll do like, you know, create post, and we'll send in the request body params, right? So you posted some information. We're going to try to create the post. If that fails for some reason, let's say it doesn't meet the validation requirements or doesn't provide the necessary columns to put into a SQL table, or maybe the SQL database is down, right? If that throws an error, we don't want it to throw an error here, because if we don't try catch this is going to throw an error, and if our Express server is not set up correctly, it's never going to respond to that request. So the user's experience is just going to hang forever in timeout, right? So we want to catch that error, and in the case of an error, we're going to say response.render, or how about a status 500 if it was our fault. If it was your fault, we might look at the error and decide, like, is the database down? Great, that's a 500, it's our fault. Is it a validation error? Then we'll throw a 400 because that's your fault. And then we'll render, like, you know, whatever is useful to communicate that this didn't work, right? So this we would actually end up doing something with a callback. So what it would actually look like, since you can't talk to a database in a synchronous fashion, and you shouldn't anyway, we would do something like, you know, if there was an error, do this part, else, you know, we render, you know, status 200, and maybe, or maybe we just redirect, or whatever's appropriate, right? So, and then if it was promises, it would be something like this. You just, you know what I mean?
So the try catch is just a synchronous way of throwing.
The try catch it only works synchronously, right? Because you keep going, right? Try catch couldn't work asynchronously because we're not waiting, right? This either throws an error right now or not, right? In this fake synchronous example, the failure is going to be thrown here, right? But we can't, if this was a promise with a callback, right? Like, for example, if we took this code here and tried to wrap it in a try catch, it's never going to throw an error. Create post is never going to throw, it's probably never going to throw an error. It's probably just going to return a promise, or just try to do some work, and if there's an error, it'll call the callback with that error, right? So this is a synchronous version of error management and control, which is totally necessary and useful to know about. And then these are both asynchronous versions of handling errors when they come in. So you might do something like this in the command line CLI or the to-do list CLI apps that you're working on, or the 321 contacts, right? So for example, if I run 321 contacts as most of us have implemented it, and that file doesn't exist, I'm just going to see like a, you know, error can't read file doesn't exist, whatever the standard file system node error is, right? We might want to present something a little prettier, or we might want to rescue that case, right? One thing we could do in that 321 contacts is if you're doing read file sync and you're trying to read contacts.json, we might do something like this. This actually is good code. This will work synchronously because we're using read file sync, which is an educational tool. We shouldn't use it in the long term, but it's good to play around with. So if there was an error reading that file, we might go ahead and just say, how about we say let contacts JSON here, and then we'll say, okay, here's my contacts JSON, and if that fails for some reason, my contacts JSON just becomes initialized as like whatever our empty version is, right? This actually probably, I'm sorry, this probably doesn't make sense for 3-2-1 context. This makes more sense for the to-do list thing. So tasks or whatever. Right, so I don't know, it depends on if you're storing your tasks as an array or as a hash, but let's say an array, right? So now we can just keep going because we can parse our JSON. Right? We could even do something like this. If we don't want tasks JSON, we just want to parse right away. We could do, we're going to wrap this in JSON parse. And if there was an error in either reading the file or parsing the file, we could look at that error and decide what to do, but we could also just say, all right, there was an error. Let's just start blank. Right? And maybe we could log an error. So that's another example of rescuing from something that failed. All right, cool. We spent half this on callbacks and promises. Should we move to the next one? Yeah, okay. Setting up Mocha. So we need an package JSON, Mocha and Chai. So who was asking about this one? It was you? Cool. So makes sense so far? So we have Mocha and Chai installed. We actually don't need to configure this. We should, but we don't have to. This is just basically like a little alias, right? We can totally make our test directory and put a test file in here, and we can start testing something. But we have to get Chai, right? Mocha, when you run the Mocha command on a test, like Mocha does some pre-work to get this global variable set up for you, so you don't have to require Mocha in every single file, but you do have to require Chai, but I'll show you a trick about that. So we'll require Chai, and we'll use expect, and we'll do expect 1, 2 equal 2, and we'll run Mocha on that specific test file. And we see that it ran, right? You can also just run Mocha, and it assumes that you have everything in test, and it will look for any files that are in there. You could also give it like a complex expression. You could do anything in test that ends with .test.js, right? So we can see if we use echo what that explodes out to. If we had another one, right? This explodes out to a list of all those matching files. So we can just say mocha test star.test.js, and it'll run just those files that end in .test.js.
So with Mocha and Chai, you have to test while you're using a test directory?
No, you can do any file, right? If we had, whatever, an app directory where we had our, web server.js, and then we wanted to write tests for that, right? So now here's our app directory, right? We've got our real code and then the test for our code right alongside it. If you want to do that, you just need to tell Mocha where your test files are. So maybe we'll do something like app.star.test, and it'll well, there's nothing in there, but it'll just run our test for that. So we're testing our web server. It should, serve some web, right? And so if I wanted to have my tests like all next to my code, which is a thing people like to do, then you just need to make sure you tell Mocha how to find all those test files, which is why this becomes a good idea, right? Because now you just say npm test, and it knows how to go find all your test files. Yes. Oh, the question is, what is package lock? This is something new to npm. It's like the latest version. It's just extra information about the versions of all the things you installed. The reason it's there is so that if you on your machine and on my machine, we both check out a repository and we npm install, you might get a slightly different version of a package than I got. So it can cause issues where there's a bug on your machine that's not on my machine because you're using an older version of something, right? So they recently added this. This is their response to Yarn, which was a tool to do this exact same thing, which is exactly like Bundler for Ruby. It just takes the version management and says instead of just saying I can use any chai that's this version or higher, but only this number. That's what this caret means. Any whatever the last trailing number is, we can go up in that number, right? Instead of allowing you to have 402 and me to have 403, this thing is locking specifically to what version was installed. And if I check that in, that means when it's on your machine, you'll only install the exact version, right? So it's an additional level of resolution on what your dependencies are. Nah, it gets generated for you. You don't need to worry about it. Just make sure you're checking it in. What do you mean immediately invoked?
Well, like, I don't know, for Express, maybe you want to do require Express and then have the curly bracket.
No, that's just that. No. I know what you're saying. Yeah, these things here. So we have a web server file, right? So if we get Express, the question was about like sometimes requiring packages get immediately invoked, and that's because you've seen code like this, right? But that's exactly the same as if I just stored Express and then said app equals Express, right? It's exactly the same. I'm just not assigning it to a variable.
That's why, in the case of chai, we're not.
Yeah, so you might see sometimes people will do, I just want expect off of chai, and so I'll just grab expect, and then I don't do that part, right? That's the same stuff. Cool. But that brings me to my next thing, which is even though we have this set up, we're going to have multiple test files, and they're all going to have to require do the same sort of setup. In this case, we just have chai, and we're using expect. But what if we had some chai plugins and stuff? Like we'd have to configure that stuff the same in the top of every file, which gets annoying and duplicative or whatever. It's repetitive. So there's a way in Mocha to require a file before all the tests run. So you might do something like this where you make like a mocha config file, and in your test command you'll say, and I think it's mocha-r. I did mocha-help, and it's -r for require. So here we'll use the long one. We'll say require./mocha.config.js. So it's going to require this file before it runs all of our tests. So we can do some nifty stuff like we can get rid of this in our test file, and we can go into the mocha config file, and we'll require chai, and but we'll just make these global. So now we've done something we should really never do in any of our programs, but it's something that it makes sense for the way Mocha is set up. Mocha already defines a bunch of globals, so let's add a couple more, and we can have chai and expect. And then we could even add some other helpers and stuff in here if we wanted to. So now this test that I've done here and this other test here, it should run those tests just fine. Yep, and it has expect available to it as a global variable. That's how I set up Mocha. Whether or not I'm putting everything in the test directory or I'm putting everything in next to what it's testing, it just matters how you tell Mocha what files you want to find. Is that good? We good on Mocha and chai? Okay, great. What's the next thing? HTML footers with Flexbox. Okay. Great. So we got a little web page going on here. And let's put a nav bar, some main content, and a footer. Okay. Yeah. Who was asking? You were asking about this? You were asking about? Okay. Feel free to interrupt if I'm going too fast or you have questions. So we just have these three main elements. The question is like, how do we make a sticky footer, basically? There's a bunch of different ways. I'm going to actually start with normalize at least, because it's going to set some better defaults for all the browsers to make them a little bit more similar. And I'll just use the CDN for this. And I'll link to the style sheet as well. And you'll see like a slight change where we got rid of that padding around the body there. That was the main reason I wanted to do that, because it takes off some unnecessary stuff. Cool. So then let's jump into the CSS here. So we've got our nav and our main and our footer. And up here we'll make sure that the body element is height 100 view heights and width 100 view width. So no matter what's on the page. So now with that style, how can we illustrate this? The body, I think if I didn't have this, if the body just kind of ends where the content ends, right? So if we want that sticky footer, which is inside the body's got to be at least as big as the viewport, right? So you can do this by just giving it the exact same height and width. VH and VW are the view height and view width, which are the visible parts of the page, right? The viewport. So that bumps our body up to full page there, right? So now we also want to make the body display flex and then flex direction row. No, column. Cool. It doesn't look any different, but if we start giving these folks getting a little closer, and now how do we make the main content kind of take up whatever's left? And you just do flex grow. It's like flex grow and shrink, which is like 1-1 auto, something like that. There we go. So now, in order to illustrate this, I need some more content. So I'll just make some lorem ipsum here. And now, if there's, I need, here we go. So what we don't want is the header and footer to be growing and shrinking like that. So I'm going to put flex 0, 0 on the header and the footer. And now they should just stay 100 pixels. There we go. So now you can see the footer stays at the bottom, but if the content's longer, then we can scroll. Yeah? So here's the CSS for that. This is a common thing you'll want on web pages, right? This is something that, for example, I think the curriculum app does. If there's, see how that footer stays at the bottom there, and then if the content's too long, then the footer is something you have to scroll to, right? This is called a sticky footer. And I do it with a column, right? I've got a page column and stuff, but that's a little extra work. So there you go. That's how you do it. This is flex grow and flex shrink. So it's telling Flexbox that this element should not grow or shrink, or rather it should grow or shrink at priority 0 versus grow or shrink at priority 1. So if priority 1 takes precedence, and there's probably some case at which it falls down to priority 0, but this thing, the middle main element, is the only one that's going to grow or shrink depending on how our page layout's changed. You mean like absolutely positioning the footer? It makes a ton of difference. Absolutely positioning the footer would, I mean, you could do that. You would have, but it would cut, I mean, like it would probably cut off this content rather than like at this point, right? If I got to this point, see how it stops, right? That would not happen if you used absolute positioning. You probably could make it work. There's a bunch of tricks to get this to work before we had Flexbox that probably involved maybe absolute positioning the footer and then giving the main content here like a bunch of margin bottom so that this still happened. There, you can probably, I'm pretty sure I remember implementing a sticky footer with some stuff like that, but we have Flexbox. It's very well supported now, so it's really exactly what this was designed for. So it's really the way I think you should do it. But you could do it. You can find some guides on sticky footers using not Flexbox, and it probably uses that, something like that. Cool. Good. Joining tables in SQL.
Yeah.
No one's ever been that excited about SQL joins. I guess I can just do this all in Postico. What should I do? I have a bookstore. Just books. No. All right, here I have a bunch of tables from the Trello database. So this is sort of well, not sort of, it's almost an exact clone of Trello. So we have things like boards that have many cards, and users can have boards, and boards can have labels and stuff like that. So if we look at, let's try to get all the cards for a board, right? This will be a simple join, right? So here's boards. It just has an ID and a name and some other stuff, but the ID is all we care about. And then cards has a board ID and then a bunch of other stuff on it, right? So if we want to find, so some of these are for board 4 and 3 and 2, right? So if we want to find all the cards for board 2, anyone know how to do that? Right? We don't need a join for this. What's happening? There we go. Okay, so we don't need a join for that, right? But we would need a join if we were going to say, look at the user boards table, right? And so user 1 is on board 1, 2, and 3, right? So what if we wanted to find all the cards for all the boards of user 1, right? We know it's user ID 1. We need to get all the boards, and then from that, get all the cards. Let's try to write that. So it's going to be user ID 1. So let's start out with select from user boards. I can't make this any bigger, I'm sorry. Where user ID equals 1. Right, so we get board ID. So we actually want to select board ID, right? Okay, so but what we actually want is to select star from cards, join join user boards on user boards.board ID, where user boards.board ID is equal to cards.board ID, where user boards.user ID equals 1. Cool. So we're going to select all the cards. but we're going to join. So let's get rid of the where clause and look at this, right? So actually, let's start here. If we just select all the cards, this is the table that we get. So we're just going to select cards.id and cards.board ID just to get a subset. So here's our table, right? Then we're going to put back this join, but we're going to not have the where. So we're going to join user boards.star. So I'm selecting a subset of this just because cards has a bunch of columns, but basically every time you do a join, it's like you get a new table where those two tables were joined together on some condition, right? So, and then the difference, those tables can turn out differently if you're doing an inner join or an outer join, and or a left join and a right join. I forget what the default one is. We should look that up. But here we've got a join of cards and user boards where we can say, see how we have two board ID columns? That's actually cards board ID and then user boards board ID. Those are the things that we're connecting with, so those should always be the same here. Right, so in every row here, you'll see that board ID and board ID match. So we have the card ID and the user ID. And the user ID is coming from user boards. So this is joining for every single user, right? So now that we have this joined table, we can put our other condition on here, which is where user boards user ID is equal to user one. And we'll now only get the subset, right? So if we wanted just the card IDs, we can get rid of all this, and we get, these are all the cards that are associated to boards for all the boards that the user is associated to. Yes.
I know it might seem silly, but because of how like SQL is kind of created, would you say like when you're trying to set up joins to kind of say it out loud to keep the, because like the way you're saying is like you kind of do need to say it's like select this to get this to get that, because that's one of the things I keep getting hung up when it comes to joins. It's like right when I get to the where, and it's like it feel like I've thrown off my whole table.
Yeah, so the where part is like a filter. It's like an array.filter, right? You've got this big table. Maybe it's a table that exists in the database or a table that you've created via a join. And once you have that table, you're sub-selecting. You're selecting a subset of that table, right? So the where part, the join part rather, is how you get your data all together and connected. And the where part is how you slice out a subset of that. So it's helpful to build your query one at a time. If I end up just wanting the ID of cards, like I did here just now, I'll put additional data, and I'll pause my where clause, and I'll just start looking at like what are the results of this query as I build it step by step. And there are a bunch of good challenges that I can't go through off the top of my head here, but where you have like situations like you know, like a social network friend situation where like we can all follow, like let's think Twitter, right? We can all follow each other, right? And you want to find like the people who are following you, and all those relationships are in one table. I think that requires that you join to that table more than once, right? So there's some cases where you're joining the same table into itself to illustrate relationships. There's some there. We used to have that in a goal, and I don't think it's in a module, but it's an interesting exercise to practice some of that more challenging SQL joins. I would get to the point where you can join one or two tables together, and that gives you a ton of power, and it gives you a ton of power to model a lot of data models. So just some simple single and double joins is about where I suggest folks get to, probably to most of phase 2, I would say. Any other questions on that? And there's like a quick join thing. Otherwise, we will talk about regular expressions for 5 minutes. Or we won't, because Sabrina's gone. Well, if anyone has any questions about SQL joins or regular expressions, I'm happy to answer them. Any questions at all?
What's your background on your wallpaper?
I have no idea. This is oh, go back. There we go.
Is that a cat in a helmet?
From
That cat
two-
looking in-
It's from 2001 Space Odyssey, but with a cat instead. I just have like a giant Dropbox folder that several of my friends and I like put desktops in, and then we just have it on like rotate.
Oh, nice.
So I don't know that I've seen this photo before. All right, cool. Let's call it. Thanks, everybody.
Thank you.